Hello, you. Welcome to the deep dive. If you're here to work on your English, well, you're definitely in the right place.
Absolutely. One of the best ways to learn, I think, is just exploring topics you find interesting.
Yeah, you pick up words, different ways people explain things, and it doesn't even feel like hard work sometimes.
It sticks much better when you're actually curious about the subject matter.
And today, we've got a really important one. We're diving into the greenhouse effect, using a really clear explanation we found in a YouTube video from Study IQ IAS.
Now, that might sound a bit technical, maybe.
It might, yeah. But don't worry, our whole mission here is to break down the key ideas from that video. We want to help you understand this global issue, but also show how listening closely to this kind of material can really boost your English.
You start to see how even complex ideas can be explained clearly.
Exactly. So, our source is the transcript from that video. Okay, let's get started. What exactly is this greenhouse effect?
Well, basically, it's a natural thing the Earth does. It gets energy from the sun, right? Solar radiation. This warms up the planet's surface. Then, some of that heat radiates back out towards space.
Right, it tries to escape.
But there are these specific gases in our atmosphere, greenhouse gases, and they trap some of that outgoing heat. That's what keeps the Earth warm enough for us.
Okay. The video had a really good analogy for this, didn't it?
Yeah, the actual greenhouse, the glass buildings.
For growing plants, yeah.
The glass lets the sunlight in, but then it traps some of the heat inside, keeping it warm for the plants. It's a similar idea with our atmosphere and these gases. They act like an invisible layer of glass, or maybe like a blanket.
A blanket keeping the earth warm. Got it. And
Yeah.
this is actually good.
Oh, absolutely vital. This natural greenhouse effect is crucial. It keeps the Earth's average temperature at around 15 degrees Celsius.
15
Comforting.
degrees. Okay. But the video made this really stark contrast. What if those gases weren't there?
Right. Without them, the average temperature would drop to about minus 18 degrees Celsius.
Minus 18. Wow.
Yeah, think about it. A mostly frozen planet. Life as we know it just wouldn't be possible. So the natural effect, definitely a good thing.
Okay, so natural, necessary, good. But we always hear about it as a problem. So where does it go wrong?
The problem isn't the effect itself, it's that we're adding too much of these greenhouse gases to the atmosphere, mainly through human activities.
Okay.
This leads to what's called an enhanced greenhouse effect. It's like putting too many blankets on, the Earth traps too much heat, and the planet warms up excessively.
And that's global warming.
That's global warming, exactly. The natural balance is disrupted.
Right. And the video mentioned the main culprits, the human activities causing this extra gas.
Yes, burning fossil fuels is a huge one.
Huh.
Coal, oil, natural gas. We use them for energy, for transport, electricity, industry.
And that releases these gases.
Loads of them. And another major one mentioned is deforestation, cutting down forests.
How does that fit in?
Well, trees are amazing because they absorb carbon dioxide, one of the main greenhouse gases, from the air. So when we chop down forests, we lose that natural CO2 removal service.
Right, less absorption. Okay, so which gases are the main ones we're talking about here, the ones causing the extra warming?
Well, the most famous one is definitely carbon dioxide, CO2.
Okay.
A video explained it's pretty much transparent to the sunlight coming in, but when the heat tries to radiate back out from Earth, CO2 is really good at absorbing and trapping it.
And we're putting more and more of that in the air.
Yes, concentrations have been rising significantly, but it's not the only one. Methane is another big player, CH4.
Methane, right.
Yeah.
How does that compare?
Well, molecule for molecule, it's actually much more potent at trapping heat than CO2, especially in the shorter term, like over 20 years or so.
Wow. Okay. And where does methane come from?
The video pointed to things like agriculture, livestock, like cows, produce a lot of it. Also the production and transport of natural gas and certain fertilizers. Oh, and it mentioned gobargas, which is biogas, largely methane.
Interesting. Cows and gas leaks contributing significantly. What about nitrogen oxides? That sounds like more than one thing.
It is. It includes gases like nitric oxide, NO, and nitrogen dioxide, NO2. Now, this part's a little more complex.
Okay.
NO and NO2 can actually indirectly cause a bit of cooling because they react in the atmosphere in ways that help break down methane.
Oh, okay. So they destroy another greenhouse gas.
Sort of, yeah. But there's another nitrogen oxide, nitrous oxide, N2O. That one is a powerful greenhouse gas itself, and it lasts a long time in the atmosphere.
Ah, okay. N2O is the one to worry about in terms of warming. And where does that come from?
Again, agriculture is a big source, particularly the use of nitrogen fertilizers, also some industrial processes and burning fossil fuels.
Got it. So CO2, methane, nitrous oxide. big three. The video also flashed up some others with complicated names, CFCs.
Ah, yes, the manufactured gases, chlorofluorocarbons, CFCs, hydrochlorofluorocarbons, HCFCs, perfluorocarbons, PFCs, sulfur hexafluoride, SF6.
Phew. What's the deal with those?
They're mostly industrial chemicals used in things like refrigeration, air conditioning, and manufacturing. CFCs were particularly bad because, besides being potent greenhouse gases, they were also destroying the ozone layer.
Right, the ozone hole.
Exactly. That's why the Montreal Protocol was created back in 1987 to phase them out. HCFCs were often used as replacements, though they also have issues. PFCs and SF6 are extremely potent and very long-lasting greenhouse gases.
Okay, so mostly man-made industrial gases, powerful warming effect. There was one more thing mentioned. Black carbon. That's not a gas, is it?
No, it's not. It's basically soot. Tiny black particles produced when we burn fossil fuels or biomass, like wood or crop waste, but don't burn them completely.
Okay, soot, how does that cause warming?
Well, unlike gases that trap outgoing heat, black carbon absorbs incoming sunlight directly. It heats up the air around it, and when it lands on snow or ice, it darkens the surface.
Making it absorb more sunlight instead of reflecting it.
Precisely. Like wearing a black shirt on a sunny day.
That's a lot of different contributors.
Yeah.
So what actually happens when we have too much of this warming? What are the effects the video highlighted?
Well, the most direct effect is the rise in global average temperatures. We're seeing that already.
More heat waves and stuff.
Yes, exactly. And linked to that is the melting of ice caps, glaciers, ice sheets.
Which leads to sea level rise, right?
Yes. The video explained its two main things: the meltwater from land-based ice running into the ocean, and thermal expansion.
Thermal expansion.
Yeah, as water warms up, it actually expands slightly. It takes up a tiny bit more space. When you warm up the entire ocean, even by a small amount, that adds up to significant sea level rise.
Wow. Okay.
Okay.
And that threatens coastal areas.
Hugely. Coastal cities, entire island nations. Plus, we're seeing more extreme weather events, stronger hurricanes, more intense rainfall in some places, deeper droughts in others. The whole climate system gets disrupted.
And didn't the video mention the ozone layer again and the effects?
It did. While CFCs are the main direct cause of ozone depletion, the broader changes in atmospheric temperature and circulation caused by the enhanced greenhouse effect can also affect how quickly, or even if, the ozone layer recovers.
Ah, okay. It's all connected.
And remember, a thinner ozone layer lets more harmful UV radiation reach the surface. That increases risks like skin cancer.
Scary stuff. What about other environmental impacts? Smog, water.
Yeah, smog and general air pollution often come from the same source as burning fossil fuels, so they're linked problems. And for water, a big concern mentioned was ocean acidification.
Acidification. Like acid rain.
Sort of, but in the ocean. The oceans absorb a huge amount of the extra CO2 we put in the atmosphere. When CO2 dissolves in water, it forms carbonic acid, making the water slightly more acidic.
And that's bad for marine life.
Very bad, especially for things that build shells or skeletons like corals, oysters, mussels, and tiny plankton at the base of the food chain. The increased acidity makes it harder for them to build those structures.
Right. Weakens the whole ecosystem. And the video mentioned something really alarming, a runaway greenhouse effect.
Yeah, that's a potential worst-case scenario. It's basically a feedback loop where warming triggers processes that release more greenhouse gases, which causes more warming and so on.
That vicious cycle.
Exactly. For example, warmer temperatures mean more water evaporates. Water vapor itself is a greenhouse gas, so more water vapor traps more heat, leading to more evaporation. You see.
Yeah, it feeds itself.
Another worry is methane trapped in permafrost frozen ground in the Arctic. If that thaws, huge amounts of methane could be released, massively accelerating warming. It's the kind of scenario that could theoretically make Earth much less habitable.
That's a really sobering thought.
Yeah.
And beyond the physics and chemistry, there are impacts on living things, on us.
Absolutely. Ecosystems struggle to adapt to rapid climate change. We see shifts in where plants and animals can live and, unfortunately, increase extinction rates, biodiversity loss. And for humans, changes in weather patterns, droughts, floods. They directly impact agriculture and food production. Food security is a major concern.
It really touches everything. Okay, so facing this huge challenge, the video talked about the greenhouse gas protocol. What role does that play?
Think of it as an accounting system. It provides internationally accepted standards and tools for businesses, cities, and countries to measure and manage their greenhouse gas emissions.
So like rules for counting.
Pretty much. It helps everyone measure emissions in a consistent way, covering different sources like direct emissions from factories, emissions from the electricity they buy, and even emissions in their supply chains. You can't really manage or reduce something if you can't measure it properly.
Makes sense. Standardized measurement is key. Who developed this protocol?
It was a collaboration primarily between the World Resources Institute, WRI, which is an environmental think tank, and the World Business Council for Sustainable Development, WBCSD, a group of large companies.
Interesting mix. Business and environmental groups.
Yeah, they saw the need for standardized accounting back in the late 90s, around 1997, and developed the first standards by about 1999. It's become the global standard.
Good to know there are frameworks like that.
Hmm.
Okay, just to wrap up the causes, the video summarized the key drivers behind why emissions have increased so much. We hit some already.
Right. Burning fossil fuels for energy is the big one. Transportation, electricity, heating, industry.
Okay.
Population growth is also a factor. More people generally means more consumption and energy use. Linked to that is increasing consumption levels per person in many parts of the world.
More demand for stuff.
Exactly. Then there's deforestation, which we talked about, reducing the planet's capacity to absorb CO2. And finally, agricultural practices, particularly methane from livestock and nitrous oxide from fertilizers.
Okay, quite a list. So let's try a quick recap. Greenhouse effect. Natural. Essential. Enhanced greenhouse effect. Too many gases. CO2, methane, N2O mainly, plus others. From human stuff like burning fossil fuels, cutting forests, farming. This causes global warming.
Right, leading to rising temperatures, melting ice, rising seas, wilder weather.
Impacts on oceans, ozone, ecosystems, food. And we have tools like the Greenhouse Gas Protocol to try and measure and manage the emissions.
That captures it well. And, for you listening, especially if you're using this to improve your English, think about all the specific vocabulary we've used.
Yeah, words like radiation, absorb, emit, potent, mitigation, acidification.
And different ways of explaining cause and effect, comparing things, talking about processes, engaging with real-world material like this video transcript is such a powerful way to learn.
It really is. You're tackling a complex, important topic, but you're also practicing listening, understanding structure, picking up new words and phrases naturally. It's learning through the content.
Much more engaging than just memorizing lists, I find.
Totally. So maybe a final thought for you to consider. How does understanding the language used to discuss something complex like climate change actually empower you? Not just intellectually, but in your English journey too.
That's a great question. Being able to understand and maybe even talk about these big issues is a real skill.
Definitely. So keep exploring, find other topics that interest you, listen to podcasts, watch videos in English. It really is a fantastic way to learn.
Well said. Thanks for tuning in for this deep dive with us today.
Yeah, thanks for joining us. We hope this look at the greenhouse effect was helpful, both for your understanding and your English.